So we're going to go ahead and take a look at differentiability at a point, but algebraic, and this is probably going to be some of the most work you're going to do all semester as far as this calculus goes, as far as algebra as well. So it's a great test because we have to focus on continuity and differentiability. Why? Well, guess what? If it's not continuous, which is a possibility from this piecewise, remember, if it's not continuous, it falls under the form of not being differentiable. So we have to check continuity, and then from there, we have to check the derivative from the left and the right. Make sure the slope from the left and the right-hand side of 3 is the same. So I know even though it equals 3 here, we do have to check both sides. So let's go ahead and start with the continuity test. So that's just the classic one. Plug in a 3, so we have our left-hand limit is 3 squared, which is 9. And then we have our right-hand limit, which is 6 times 3 minus 9, so 18 minus 9, which is 9. So both are the same, so it passes the continuity test. Now let's go ahead and focus on the differentiability test. And we learned, let me rewrite the function. So we learned a couple different formulas. We're going to go ahead and use this formula for it. It's a little easier. Just that classic slope formula, right? y2 minus y1 over x2 minus x1. And there's our function. I had to rewrite it because it's going to be a whole lot of work down here. So let's start with the left-hand derivative. So we're going to find the slope at 3 using the x squared. And f of x, we're going to use for the left-hand derivative, we're going to be using x squared. So we'll have x squared minus 3 squared. So that's x squared minus 9 over x minus 3. So then we factor the top as x plus 3x minus 3. Then we can cancel out the x minus 3's to be left with the limit as x approaches 3 of x plus 3, which is 3 plus 3, which is 6. All right, that's just the left-hand derivative. Let's go ahead and do the same thing for the right-hand derivative. So we'll use the 6x minus 9. So f of x is 6x minus 9, and then minus, we got to put parentheses because we're going to subtract the whole thing. If we plug in a 3, you get 6 times 3 minus 9. So we get 6x minus 9, then minus 18 plus 9 over x minus 3. And then negative 9 plus 9 goes away, so we have 6x minus 18. Factor out the 6. X minus 3's cancel out, and we're just left with 6. So are they the same? Yes. The derivative from the left and the derivative from the right are the same. If they were different, then it would not be differentiable. Had to do all that just to test it. So the derivative from the left and the right is the same. So it passes the differentiability test. So since it's continuous and differentiable, both continuous and differentiable, Let me show you one of these. There's no way you can have it differentiable but not continuous, because remember, we need continuity in order to have differentiability. It's possible to have continuity and not differentiability, but you're not going to have this. All right, let's go through another example. I know it's going to take quite a bit of time, but we might as well. So let's do the continuity test. So left-hand limit. Which gives me -4 plus 3 is -1. Right-hand limit. It's going to give me 4 minus 5, which is also -1. So it passes the continuity test. Let's go ahead and do the derivative now. So we'll use this one first. So it'll be f of x, which is -x squared plus 3, minus f of 2, is just plugging the 2 in there, which we found to be -1 earlier, right? Three plus 1 is 4. I'm going to factor that negative out. Have x squared minus 4. Which then becomes x plus 2x minus 2. X minus 2's cancel out. Plug it in, and we get -4 for our answer. All right, whole lot of work there. Right-hand derivative. So we're going to use this one this time. So we're going to have x minus 4 squared minus 5. And if you plug in the -1 into here to get f of, or not -1. If we plug in the 2 into there, we get -1, right? If we plug in the f of 2, is going to be -1. So minus -1 all over x minus 2. Let's see what happens with this one. I'm going to zoom in this time. So we'll get x minus 4 squared is x minus 4 times x minus 4. If we expand that out, right? And then -5 plus 1 is -4. And then foiling that out, we get x squared minus 8x plus 16 minus 4. So that's x squared minus 8x plus 12 for x minus 2, which then is x minus 6, x minus 2. Cancel out the x minus 2, and we're left with x minus 6. So let's go back up, bring the limit into all this. And we plug in a 2, 2 minus 6 is -4. So this one actually checks off again. Both examples worked out. -4, -4. So it passes differentiability. So this one is also both.